Hello everyone, I am Karthik HB from BMS College of Engineering, Bengaluru. Today I will be explaining about an important concept from thermodynamics. In that I am explaining some introduction part, like I am explaining about open system and steady flow system. I am covering in that some concepts like flow energy, shaft work and throttling process with some examples and diagram. We all know thermodynamics is the study of energy, how it is transferred, converted, and used for some operations. In real life engineering systems, energy can cross the boundaries of a system in many forms, such as heat, or work, or energy, depending on how mass and energy interact. We classify systems as open, closed, or isolated. In this presentation, we are mainly focusing on open systems, which are also called as the control valid system, and how they behave under steady flow conditions. First, I would like to explain about open system. It is also known as control system or flow system. It is the basic diagram of the open system. Mm, we are discussing about the next open system. Open system is one in which both mass and you can see the diagram, both mass and energy can exchange. That means cross the system of the boundary. Like some examples including turbines, compressor, pumps, nozzle, or moving cylinder piston with only inlet, boilers, and nozzles. We know, for instance, in a steam turbine, steam enters at high pressure and leaves at low pressure while doing work on the turbine blades. So both mass and energy transferred, making it an open system. Here you can see in a diagram the mass entering from one side and the mass leaving from the another side, along with the heat also entering from one side and work is flowing out in one side. In that open system, mass input is equal to mass output. Control value may be fixed or it may be vary. Next, I would like to, in that open system, there are two types: energy term for non-flow system and energy term for flow system. It is all about energy flow in non-flow system. Like some of the energies when the flow in non-flow system, some of the energies means internal energy plus kinetic energy plus potential energy. If we write the formula of this, it is look like the second one. If we divide it by the mass, then look like that third equation. In specific term, it is represented by using the small letters like E non-flow is equal to internal energy plus kinetic energy plus potential energy. And next one is energy term for flow system. It is also same like non-flow system, but it involves some enthalpy for flow system. Like it is involve enthalpy plus kinetic energy plus potential energy. Like it is write the equation and divided by mass, it gives the third equation. We know that in specific term represented by the small letters like E flow is equal to enthalpy plus kinetic energy plus potential energy. Next, I would like to discussing first law for steady open system. It is a basic equation related to steady open system. You can see the rate of heat transfer and work, that means power, and some using enthalpy change. It is the mass flow rate. It is the steady open system formula for first law. Next, I would like to discussing about steady flow system. It is the basic diagram of the steady flow system. We can see how steady flow system works. A steady flow process means that the conditions inside the system, such as pressure, temperature, and mass flow rate, do not change with time. This means that the amount of energy entering is equal to the amount of energy leaving the system. We can see the diagram Mi, that means mass entering into the system is equal to the mass leaving the system, that means Me. So in mathematically we can say rate of change of energy within the system is zero. So it's a steady operation like a turbine running continuously under constant load and speed. It's all about the steady flow system. And the balanced equation for steady flow system is Q minus W plus m dot of H1 plus V1 square by 2 plus GZ1 is equal to m dot of H2 plus V2 square by 2 plus GZ2. It is the related equation for steady flow system. We all know Q is the rate of heat transfer, W is the net rate of work done by the system, M that is the mass flow rate system, H is the enthalpy of the system, V is the specific enthalpy, Z is the elevation. 1, 2 are used for the subscription, 1 for inlet, 2 for outlet. Next, I will move to the flow energy. In flow energy, I am basically discussing about the some concepts. Flow energy, it is also known as the flow work, is the energy required to push the mass of the any item into or out of a control volume. It is given by the formula flow work is equal to P multiplied by V, that is P times of V. That means where P is the pressure and V is the specific volume. You can visualize this using by a piston. When fluid enters or exits the cylinder, work is needed to push it in or out against the pressure. It is also called the flow energy. Basically, the energy needed to move the fluid into or out of the system boundary. It is called flow energy. Already discussed. It is all about the flow energy. Next, I am moving to shaft work. It is the basic diagram of the shaft work. Discussing about the shaft work. Shaft work is a energy transmitted through a rotating shaft. We can see in the diagram. Mm, In turbines, the fluid expands and rotates the shaft, producing shaft work output. In compressor and pumps, the shaft is rotated by an external source like a motor, so they consume shaft work. We can see that they are using a motor in the doing process. The formula is T multiplied by V. T means torque and W is the angular velocity. Shaft work is important in mechanical devices because it is directly relates the power generation and energy conversion. Some example like pumps, compressor, turbines and stirrers. Open system, it is a crucial component in the energy balance of open system like pumps and turbines. We know that it has discussed about the energy transfer and shaft work. It's all about the shaft work. Now I am moving to last concept of my explanation, that is throttling. It is the diagram of the throttling. Some discussing about the throttling. Uh, it is one interesting one concept. The throttling process. A throttling process is a steady flow process with no heat transfer and no work transfer. It is usually occurs when a fluid passes through a valve or a porous plug. We can see in the diagram, resulting in a drop in pressure. Like the key property of throttling is that enthalpy remains constant, meaning H1 equals to H1. We can see it is also called as the ice enthalpic. That means H1 is equal to H2. For example, in a refrigerator system, the expansion valve uses throttling to reduce pressure in refrigeration and the temperature of the refrigerant. Similarly, in throttling calorimeter, steam expands through a small opening and its pressure drops. Like we considered in that throttling there is no work done, so work done is equal to zero. Temperature changes depending on the fluid, that means what type of liquids we are using. If you use ideal gas, temperature remains constant because enthalpy only enthalpy is a only function of a temperature. If you are using a real gases in a throttling process, the temperature typically drops. That means temperature varies because it is not the function of the enthalpy. It is observed by using the Joule-Thomson effect. It is an effect used to observe this process. It's all about the throttling. Mm, in conclusion, we are understanding the opening system and the steady flow system helps to engineer design efficient turbines, compressor, and cooling devices. It's all about the my concept. These concepts are not just theoretical; they are applied in every power plant, engine, and refrigeration system around us. Thank you for listening my explanation. All of you, thank you.